Everything begins when you look up at the sky. Five people, 5 ideas about the sky, all written down before anyone owned a telescope. That the sun is a burning stone. That the pale band across the night is countless suns. That the earth is not the center of anything. That the world can be measured with a stick and a shadow. Every one of them turned out to be true. Not one of them could be proved at the time. This is what they saw, and how long it took us to catch up. 2,300 years ago, on a Greek island, a man worked out that the earth moves around the sun. He had no telescope, no physics of gravity, no mathematics beyond geometry. He had his eyes, and he had time. He was right. And for the next 1800 years, almost nobody believed him. This is a video about 5 people who looked up at the same sky you can see tonight, and guessed something extraordinary. And about the moment, centuries later, when we finally found out they were correct. Some of them were put on trial for it. Some were ignored. One was simply forgotten, and had to be discovered all over again. You do not need to follow anything closely. There is nothing to remember. Just the sky, and the people who looked at it before us. Around the year 450 before the Common Era, in Athens, a man named Anaxagoras said something that got him put on trial. He said the sun was not a god. He said it was a stone. A mass of burning metal. He called it larger than the whole Peloponnese. To us that sounds almost quaint. The sun is 109 times the width of the earth. You could fit more than 1 million earths inside it. The Peloponnese is a piece of land you can drive across in a morning. But set the size aside, because he had the important part exactly right. The sun is not a deity riding a chariot across the sky. It is a physical object, made of ordinary matter, and it is burning. He went further. He said the moon does not shine. It only reflects the light of the sun. He said the moon has mountains and plains, like the earth. And he explained eclipses correctly, as one body passing into the shadow of another. We know now that he was right about all of it. The moon has no light of its own. Men have walked on those plains. The mountains he inferred from nothing but the pattern of shadows are photographed today in detail fine enough to pick out individual boulders. And there is something quietly astonishing in that. He reasoned his way to the truth about a world he would never reach, from nothing but the way light fell across its face. 2,500 years later we went there, and found exactly what he had described. There is one more thing. Around the year 467, a large stone fell out of the sky near a river in northern Greece, at a place called Eratosthenes. People treated it as an omen. Anaxagoras said it was simply a piece of rock that had fallen from the heavens. That is what a meteorite is. He is the first person we know of who said so. He was charged with impiety, and he left Athens. There is a crater on the moon named after him now. At around the same time, another Greek was looking at the pale band that crosses the night sky. Aristotle would later say it was a kind of glow in the upper air. Weather, essentially. And because Aristotle said it, that is what most of the world believed for the next 2,000 years. Democritus said something else. He said the Milky Way is made of stars. Countless stars, too faint and too close together for the eye to separate. He had no way to prove it. There was no instrument anywhere in the world that could resolve that band into anything at all. In 1610, Galileo turned a telescope towards it, and the band dissolved into individual points of light. More than he could count. Today we know our galaxy holds somewhere between 100 and 400 billion stars, spread across a disk about 100,000 light-years wide. When you look at that faint band, you are looking edge on through the galaxy you live inside. Democritus was right, and he was right for the right reason. He simply had the misfortune of being right in a century that had no way to check. We should be honest about one thing. His own writings did not survive. We know what he said because later authors quoted him. That is true of a great deal of ancient thought. What reaches us is often an echo of an echo. But the echo is clear enough. Which brings us back to the man on the island. Aristarchus of Samos, born around 310 before the Common Era. His book is lost. Every copy of it. We know what was in it because Archimedes described it in a work called The Sand Reckoner, and that one survived. Archimedes wrote this. But Aristarchus of Samos brought out a book consisting of some hypotheses, in which the premises lead to the result that the universe is many times greater than that now so-called. His hypotheses are that the fixed stars and the sun remain unmoved, that the Earth revolves about the sun in the circumference of a circle, the sun lying in the middle of the orbit. The fixed stars and the sun remain unmoved. The Earth revolves about the sun. That is heliocentrism, written down 18 centuries before Copernicus. And it was rejected. Not out of stupidity. Out of good reasoning built on one wrong assumption. The argument went like this. If the Earth really travels in a great circle around the sun, then over the course of a year the stars should shift. Look at a nearby star in summer, then look again in winter from the far side of the orbit, and it should appear to move against the ones behind it. That shift is called parallax. Hold up your thumb and close one eye, then the other. Your thumb jumps. Same principle. Nobody could see it. Not one star moved. So either the Earth was standing still, or the stars were unimaginably far away. Aristarchus said the stars were unimaginably far away. He said the sphere of the fixed stars was so vast that the entire orbit of the Earth is like a single point at its center. He was right. And he was asking people to accept a universe hundreds of thousands of times larger than anything they had reason to believe in. A philosopher named Cleanthes said Aristarchus ought to be charged with impiety for putting the heart of the universe into motion. The shift he predicted was finally measured in 1838. Friedrich Bessel, watching a star called 61 Cygni through a telescope Aristarchus could not have imagined, detected a wobble of about 3/10 of 1 arcsecond. That is roughly the width of a coin seen from 6 miles away. 2,100 years after Aristarchus said it would be there. Sit with that for a moment. He predicted an effect too small for anyone to detect for 21 centuries, and he was right about why they could not detect it. About 80 years later, in Alexandria, a librarian measured the Earth. Eratosthenes had heard that in a town to the south called Sene, on one particular day of the year, at noon, the sun stood directly overhead. Sunlight reached the bottom of a deep well. Upright objects cast no shadow at all. On the same day, at the same hour, in Alexandria, objects did cast a shadow. He measured its angle. About 7.2 degrees. 7.2 degrees is 1/50th of a full circle. So if those two cities were 1/50th of the way around the Earth from each other, then the whole circumference was 50 times the distance between them. He had that distance. Roughly 5,000 stadia. 50 times 5,000 is 250,000 stadia. We are no longer certain exactly how long his stadium was. Depending on which value you use, his answer works out to somewhere between about 39,000 and 46,000 kilometers. The real figure, measured today by satellites, is 40,075. A man with no instrument more advanced than a stick, working from the length of a shadow at noon, measured the size of this planet to within a few percent of the number we now get from spacecraft. And what strikes me about that is not how clever he was, though he was. It is that the Earth was willing to tell him. The information had been lying there the whole time, written in a shadow, waiting for somebody to think of the right question. The last one is a Roman, and he is my favorite, because he knew he was going to be proved right by people he would never meet. Seneca, writing around the year 62, in a work called Natural Questions. The subject was comets. In his time the standard view, Aristotle's view again, was that comets were fires in the upper air. Weather. Nothing to do with the stars. Seneca disagreed with his own school. He wrote, In none of the ordinary fires in the sky is the route curved. It is distinctive of a star that it describes a curve in its orbit. A comet has its own settled position. For that reason it is not expelled in haste, but steadily traverses its course. It is not snuffed out, but takes its departure. A comet has its own settled position. It travels a course. It does not go out. It departs. He is describing an orbit. And then he wrote something I find genuinely moving. The day will yet come when the progress of research through long ages will reveal to sight the mysteries of nature that are now concealed. The day will yet come when posterity will be amazed that we remained ignorant of things that will to them seem so plain. And this? Men will someday be able to demonstrate in what regions comets have their paths, why their course is so far removed from the other stars, what is their size and constitution. Let us be satisfied with what we have discovered, and leave a little truth for our descendants to find out. In 1705, Edmund Halley looked at the records of comets seen in 1531, 1607, and 1682, and realized he was looking at the same object 3 times. He worked out its orbit, and predicted it would return in 1758. He died in 1742. He never saw it. On Christmas night, 1758, a German farmer and amateur astronomer named Johann Pallich found it. Exactly where Halley had said it would be. 17 centuries after Seneca wrote that men would one day demonstrate in what regions comets have their paths, a man did precisely that. And then died before the proof arrived, and was proved right anyway. Seneca asked his descendants to leave a little truth for the ones who came after. We did. None of these people had instruments worth the name. They had the sky, and patience, and the willingness to say something that sounded absurd. Some of them were wrong about the details. Anaxagoras had the sun far too small. Aristarchus had his distances badly off. Eratosthenes was working in a unit we can no longer measure precisely. That matters less than you might think. What they got right was the shape of the answer. And here is the part worth sitting with. Every one of them was looking at the same sky that is above you now. The same sun. The same faint band of light. The same comets on the same long orbits, still traveling, still coming back. They looked up with nothing, and reasoned their way to the truth. We look up with telescopes in orbit and spacecraft beyond the edge of the solar system, and we confirm what they suspected. Somewhere out there is something we are getting wrong tonight. Some obvious thing, sitting in plain sight, that somebody a few hundred years from now will find, and wonder how we missed it. Seneca knew that too. Leave a little truth for our descendants to find out. Good night.